to go. What we have today is derived quantities. From the previous lesson, I have explained the fundamental quantities, which is defined as the basic quantities that are independent of others, that cannot be determined in terms of other quantities. And the quantities are length, mass, time, electric current, temperature, and the amount of substance. So those are the fundamental quantities. While their units are called the fundamental units. They are the fundamental units. So today it is the derived quantities. So the derived quantities can be obtained by simple combination of the fundamental quantities. By simply combining the fundamental quantities, the derived quantities are obtained, and their corresponding units are called fundamental derived units. Their corresponding units are called derived units. Then examples of the derived quantities are area, volume, density, acceleration, momentum, and so on. There are many. So derived units can be formed by combining fundamental units I have explained earlier. By simply combining of the basic fundamental unit, we can easily obtain other useful units. These units are called the derived unit. Example: volume. Volume is meter times the meter, which is equal to m cube, because it's meter times meter times meter. So the unit is m cube. Then density is mass divided by volume. So therefore it is kilogram per inch cube. Kilogram per inch cube. So etc. So some of the derived quantities and their units are shown in this table. So number one is area, which is meter square. The unit of area is meter square. Volume, the unit is m cube. Density, the unit is mass, kilogram per m cube. And their definition is mass divided by volume, which is equal to kilogram per m cube. Speed is length divided by the time, which is equal to meter per second. Velocity is length divided by time, which is also meter per second, because their units are the same. The only difference between speed and velocity is speed has no direction, while velocity has direction. It is in a specified direction. So acceleration is final velocity minus the initial velocity divided by the time, which is equal to meter per second square, and force is equal to mass times the acceleration, which is equal to kilogram meter per second square. That is by combining the fundamental quantities or other quantities, then derived units can be obtained. So work or energy is half of mv square or mgh, and half of mv square is the kinetic energy, mgh is the potential energy, and their unit is joule, which is J. Then power is equal to work divided by the time, which is equal to watt. The unit of power is watt, represented as the blue. Then pressure is equal to force over area, which is equal to Newton per meter square. And heat capacity is equal to quantity of heat divided by the temperature, which is equal to joules per Kelvin. And specific latent heat is quantity divided by mass of the substance times the temperature change, which is equal to joules per kilogram per Kelvin. And specific latent heat is quantity of heat divided by the mass of the substance, which is equal to joules per kilogram. And linear expansivity is equal to the final length minus the initial length divided by the initial length times the temperature, which is equal to per Kelvin. And in scientific measurement, the system of units accepted internationally is called International System of Units, and these are also called Standard International Units. standard international unit. They are universally accepted. Anywhere you go, they are how they are. That is how they are. They are accepted. They can never change. So that is why they are called standard international unit, SI unit, or internationally accepted unit, or system international system of units. So these are some of the dry quantities that we have and their units. So dry quantity can be obtained by simply combining the fundamental units. So they are corresponding by simply combining fundamental quantities, and their corresponding units are called dry units. So that is what we have for today.